In this video on the Certified Q&A, let's tackle another question for the Google Cloud Platform Associate Cloud Engineer. It's very important to the process of understanding Google Cloud and passing the certification exam that you go through the question and attempt answering it yourself first. So pause the video, work through the question. We'll catch up in just a little while and I'll show you how I do it. In this scenario, your company processes high volumes of IoT data that are timestamped. The total data volume can be several petabytes. The data needs to be written and changed at a high speed. You want to use the most performance storage option for your data. Which product should you use? Cloud Datastore, Cloud Storage, Cloud Bigtable, or Cloud BigQuery? In answering this question, the key parts that I would look for are: 1. There's high volumes of data. The data itself is IoT data that is timestamped. The data volume is going to be petabytes, so that's a humongous amount of data, going from gigabytes to terabytes to petabytes and then beyond that exabytes, but many thousands of terabytes would amount to the data volume that you expect in this case. You also need to make sure that the data can be written and changed at high speed. So it should be optimized for write performance. Obviously, we're expecting that the read performance also should be fairly good. The question also suggests that you need a performance storage option. Now let's look at each of these and see which might fit this particular use case. One of the first things we can look at is BigQuery as an option. So the requirement is that we need high-speed data writes and data edits. Does BigQuery support that? One of the best ways to work with Google Cloud and to figure out the right solution is to follow a flowchart. There are few people online, and Google Cloud documentation itself has multiple flowcharts that allow you to figure out which would be an appropriate solution. In this flowchart, we will start with the data that we have and say which of those applies to which technologies. So now the question is BigQuery, right? Is BigQuery a suitable solution for us? BigQuery falls in the structured and SQL on the left, on the far left. Now, is our data structured and SQL based? The answer is not necessarily. Right? It could be, but it is not necessarily SQL data that we might be wanting to query. But more than that, BigQuery is not optimized for write operations. BigQuery is a very large scale, very powerful analytics or online analytics processing engine, which allows you to do reads at very high speed, but then your writes will not be that performant. So looking at this option now, we can eliminate BigQuery because it does not suit the requirement that we should be able to write and change data at very high speed. Let's look at option B, cloud storage. What is the data? It's IoT data. So this is going to be data that probably comes in as JSON or some other similar format. What is cloud storage used for? Looking at the far right, cloud storage is a blob storage that stores unstructured files. So when you have data like PDFs, videos, images, then cloud storage is your best option, or is one of the options. There are others like file store, which I have not mentioned in this diagram. So looking at the kind of data, IoT data is structured or semi-structured, whereas cloud storage is a blob storage used somewhat like a file system that is used to store files like images, videos, and PDFs. So we can eliminate cloud storage as a potential option. Now we have two left, datastore and Bigtable. Let us first see the kind of data that it supports. Both of these are NoSQL databases. So it allows you to store semi-structured data, but then you cannot query it using SQL. They're obviously not file storages either, or blob storages. Therefore, it suits the data type that we want. IoT data is semi-structured or structured data. Now, the differentiation now will be whether it supports the other requirements. On the data type that is being stored, we are good with either of these, right? But does it support high volumes, and does it support very large quantities of data? Looking back at this flowchart again, we have ticked off the part that the data is semi-structured or NoSQL, and then we've got an array of options, including datastore, file store, Bigtable, memory store, and there could be others. So on that, both Cloud Store and Cloud Data Store and Cloud Bigtable are reasonable options. Now let's go one level down on the flowchart and see what is the size of data that this is optimized for. So Cloud Memory Store typically performs well in hundreds of gigabytes of data. And of course, it is also in memory, whereas we want persistent data. So it's going to be either of the other two legs of that flowchart. In looking at the data size support there, Cloud Data Store and Firestore support in and around terabytes of data. Whereas if you want way more data, way beyond terabytes, many terabytes, then Cloud Bigtable should be your best option. So looking at the requirements here now, given that we need to have petabytes of data and that we need these writes and edits at high speed, we can eliminate data store as a potential option because it scales well to gigabytes of data and maybe up to a terabyte. But then if you want to go beyond terabytes, then Bigtable should be your best option. But what about all the other things, right? When I answer a question like this, though I've eliminated some of the options, I also want to ensure that the one that I have actually satisfies all these conditions too. So let's dig a little deeper into the Bigtable technology and see how it works. Bigtable architecture usually has requests coming in from a client, which is met at a front-end server pool. From these front-end nodes, it is redirected to multiple nodes that you can specify, which in turn then accesses data in many tablets stored in a highly scalable storage called Colossus. So if you want to have increased performance, one of the ways you can do it is to increase the number of nodes in your cluster. So just increasing nodes will increase the write performance and the read performance in a single cluster. If you want to increase, say, the read performance, then at a slight cost in write performance, you can even have replicated data with multiple clusters. But this will lose a little performance in the writes because the data has to be replicated in multiple places. There is a third thing which we didn't focus on until now, but is very important to the idea of writing data in Bigtable. So the data right now that is coming from the IoT data that is coming in is timestamped and is part of the question. So timestamp data has a very clear format that is used to say at what instant was that event generated. That would be the, I believe, ISO 8601 standard for defining a timestamp, which can be converted into an epoch time, which reads as a single continuous number. Now, Bigtable stores data in columns, right? So each column is columnar storage, and these columns are managed internally such that you can pick out rows also. Each row has a row key, and the rows itself, the row keys itself, are stored lexicographically, or essentially they're sorted. So if it's just alphabetic data, then it will be alphabetically sorted. When it's got a mix of data, it is going to be sorted in one specific order. The way IoT data is, and the way Bigtable is designed, you can make a good row key by combining certain columns within your data with a timestamp. Since it is sorted lexicographically, it is easy to take out any range of data. If you want to find out, give me all the events that occurred in the last 1 hour, it is very easy to minus the 60 minutes from the current time and read through the data from the Bigtable. If you want to also directly access one particular event or one particular row, it's very easy to construct a key. Therefore, Bigtable is a good fit when you're working with time series data. Combining all of these now, we've got the timestamp data that was a good fit for Bigtable. Bigtable is able to access data very fast and able to write and edit data at high speed. It can scale up to many petabytes of data, and therefore combining all of this, Bigtable is clearly the best solution for this requirement. What are the key learnings for us? Bigtable scales very well linearly with more nodes. As and when you add more nodes to a single cluster, the reads and writes scale proportionally. Most other technologies don't automatically scale after a certain point, and therefore you need to consider how much is that upper limit beyond which the performance probably degrades. Bigtable is able to handle petabytes of data, right? Many thousands of terabytes. Bigtable also provides very low latency, under 10 milliseconds. So this is great for IoT data where there could be a large number of devices constantly pumping information about itself. Now, cloud storage actually works with even exabytes of data, right? Many thousands of petabytes, but it does not store data in a structured or semi-structured format. Instead, it stores them as files, it stores them as blobs. So it works well with images, docs, and videos. If you want to structure data, then go down the far left of that flowchart, and you will find options like Cloud SQL, Spanner, and BigQuery. But within that, BigQuery is optimized for reads and not for high volumes of writes. Among the options for semi-structured data, NoSQL data, for example, the options you have are datastore, firestore, Bigtable, and there could be more. If you're working with time series data, especially one that needs to be accessed at high speed, that needs to be written also at high speed, then Bigtable is a great fit. In newer documentation, it is suggested that Cloud Firestore is going to be the next generation of datastore. So in the exam itself, some of the questions might still compare these two, right? Datastore is still a relevant part or integral part of some of the exam topics. So you might find that, but maybe going forward, if the questions change, there might be greater interest from Google on the Firestore than on datastore. There are a bunch of references that you can go into. Try to find out about the performance of various databases. What are the limits that you get in terms of storage and speed? And also what is the kind of data that it is suited for. I would also highly recommend that you look at and study properly the flowchart that decides the various storage options and under which circumstances should you choose which. All right, now it's time for you to like, share, comment, and subscribe. Go ahead, do that right now, because there's loads of great content coming up for learning Google Cloud and preparing for the certifications.